MSC Filtration Technologies of Enfield, Connecticut, has been on the forefront of solving tough machine tool coolant filtration and handling issues since 1962. MSC's product lines include centralized coolant filtration systems, chip handling and waste reduction equipment, chillers, oil-water separators, and centralized coolant recycling systems, just to name a few. MSC's coolant recyclers have a quick return on investment and have over the years saved our customers millions of dollars in otherwise lost revenue by increasing their tool life and machine uptime through cleaner coolant, and by allowing them to recycle and reuse over 20 million gallons of coolant and counting. This is enough coolant to fill 55-gallon drums lined for 100 yards and still form a stack almost 1 mile high. When it comes to machine tool coolant recyclers, one size very rarely fits all. MSC therefore tailor engineers each of our recyclers to each of our customers' specific needs and expectations, and is committed to the final goal of reducing our customers' new coolant purchases by up to 80 to 85%, while significantly reducing the volume of DI water used for dilution. To ensure a successful recycling program and customer experience, MSC has committed itself to being much more than just a seller of recycling equipment, and makes sure to guide our customers through the whole process of recycler design, startup, and setting up of best practices of operation. The process of setting up a successful coolant recycling program begins by choosing either a 3-tank recycler, which can recycle up to 1,200 gallons of coolant per day, or a 2-tank recycler for handling of up to 400 gallons of coolant per day. A 3-tank recycler is 1 tank broken up into 3 sections: a dirty section A, an intermediate section B, and a clean section C. Recycling begins when dirty coolant is first pumped into Section A through a primary coarse filtering system to remove gross and large particulate, such as chips or burrs. This primary filter is chosen during the recycler's design stage and is picked based on the material type being machined, along with quantity and size of particulate contamination to be expected, and is typically either a rare earth self-cleaning magnetic indexing filter for ferric particles, a self-indexing paper bed filter, or a simple bag filter. The next step in the recycling process is to recirculate coolant in tank A for a predetermined amount of time through a finer onboard bag or cartridge filter in order to remove finer particulate not taken out by the primary filter. After this predetermined amount of time, the onboard coolant pump is shut down and coolant allowed to settle in order to give tramp oils time to separate out and float to the top. While coolant settles in tank A, an onboard MSC oil-sep tramp oil separator with a floating suction is used to pull coolant and tramp oil from the top. Tramp oil and coolant mixture is then pumped through the oil-sep's separation chambers, where tramp oil is separated and concentrated, and clean coolant gravity-fed back to tank A for further processing. concentrated tramp oil in the oil sep's separation chamber is then intermittently and simply removed by the recycling operator using an onboard vacuum tank. This same vacuum system can also be used during high oil ingression rates to remove tramp oil directly from the top of tank A, which means that the MSC recycler is designed to handle large volumes of oil contamination simply and easily. To minimize coolant loss after settling, settled coolant in the vacuum tank is then drained back into tank A, while waste tramp oil is drained to a separate waste container for off-site disposal. After initial particulate and tramp oil removal from the coolant in tank A, the next step in the 3-tank recycler process is to pump initially clean coolant from tank A to tank B, and then from tank B to tank C through a second oil sep tramp oil separator for further tramp oil polishing and removal. Once tank C is full, clean coolant then overflows back to tank B in a continuous loop until both tank B and C are clean. In addition to tramp oil polishing from tank B to tank C, a final filtration recirculation step is initiated on tank C in order to polish out any fine particulate left in the coolant. Finally, the next step in the recycling process is to add new coolant to tank C as needed, using a supplied metering pump in order to make up for losses from machining waste dragout or spills, and is the last step in the recycling process before clean coolant is pumped out of the recycler for reuse in the machining centers. In addition to our high-capacity 3-tank designs, MSC offers a simpler 2-tank recycler for smaller machine shops. Our 2-tank systems are still simple to operate and well built, but have one less tank section and fewer total operating components due to the lower coolant volumes they are required to recycle. MSC's recycler designs provide a significant amount of operator control and adjustment during the recycling process, and are well built, compact, simple to operate, and include everything needed to complete the recycling process using one machine, including tank transfer plumbing along with block and bypass valves, coolant transfer and recirculation pumps, particulate filters, tramp oil separators, and for our 3-tank recyclers, a vacuum system for tramp oil removal, all of which are energized and controlled by the recycling operator using a centralized control system. To ensure proper coolant chemistry is maintained throughout the coolant recycling program, it is important to set up operational best practices to be followed once the recycler is started up. These best practices for recycled coolant handling actually start at the machine tools themselves and include ensuring that coolant in each machine is completely replaced with clean recycled coolant at least every 45 days of operation, checking coolant levels in each operational machine tool daily and topping off when levels drop below 80% of maximum, moving coolant from the machine tool to the recycler during long periods of machine downtime, and finally, measuring coolant concentrations at each machine daily, and correcting for imbalances caused by water evaporation. When imbalances are found, they should be corrected by adding a mixture of 98% water and 2% coolant concentrate to the sump as needed, compared to the standard practice of just adding 100% water. Adding some coolant to the water ensures that additives such as biocides and antifoam are continually reintroduced into the recycled coolant and can be distributed in small doses to each machine throughout the recycling process. In addition to best practices at each machine, it is important that clean coolant from tank C be tested by the coolant supplier or recycler operator at least every 2 weeks and trended at minimum for total oil acid split, biocide levels, conductivity and pH, and bacteria and fungal counts. When irregularities are found, such as increased bacteria counts, small amount of additives such as biocides should be mixed back into clean coolant in tank C. A 2-week period of testing ensures that coolant chemistry should never get too far out of range, and that only small additive adjustments need to be made rather than large adjustments, which can make coolant chemistry rebalance more difficult. Correct best operational practices are as important to a successful and profitable recycling program as choosing the correct recycler design, and are best initiated through a partnership between MSC Filtration Technologies, Plant Management and Operations, and our customer's coolant supplier. If you are interested in achieving a reduction of new coolant purchases by 80 to 85%, a significant reduction in coolant disposal costs, a significant reduction in water usage, improved machine run times, increased tool life, and receiving full technical support from selection to purchase through installation, including setting up of best practices of operation of your coolant recycler, then give MSC Filtration Technologies a call today at 860-745-7475 or visit us on the web at www.mscfiltertech.com. Thank you for watching.